So I've set up the recording. Now we are ready to start. So let's go. So basically what you're gonna do is today our mission is to do some experiments. So the first experiment is finding specific heat capacity of a solid. Everybody can hear me, right? Okay. Alright, everybody's here. Fine. Okay, now. Ali is not here yet. Where is Ali? Second, please.
Yes, sir.
Okay, Ali is here. Okay. So what you're gonna do is I'm just drawing, so you follow along, and when I'm done, you then draw. Okay? Don't draw it before I do, because then you will get it like you have to erase the things again and again. Okay. Now you can start drawing. Please draw this, and then I'll tell you what exactly this is. Okay, everybody's done. Should I explain it to you now?
Yes, sir.
Okay. So first of all, what you're gonna do is take initial temperature reading. Let's call it T1. Then turn on the heater for 5 minutes. Let's call this time T. And take final temperature reading T2. Is it clear?
Yes.
Now, let power of heater to be P. So, energy supplied is going to be power times the time. Is it clear, everybody?
Yes, sir.
And let mass of metal block be m. Okay, now what you're gonna do? Delta theta is going to be the change in temperature T2 minus T1, and we can now use the equation that power into time, basically we are doing energy equals to mc delta theta. So power into time equals to m times heat capacity times T2 minus T1. Is it clear? Hence, find the specific heat capacity. Now, the reason that we have put insulation around it so that we can prevent energy loss. This way, the heater energy will be supplied to block only. Is it clear, everybody? Any questions here? Don't get. Right. Zainab, is it clear? Soha? And
Yeah.
Afan,
Yes, sir.
Afan, what about you? Caroline, Tamoshi?
Sir, what is step 5?
In step 5, I said let mass of the metal block be m. So it could have
Okay.
mass, right? That's why.
Okay.
Right. Interesting. Okay. Now let's move to the next part. Everybody's written it. Should I go forward?
Yes.
Now, the next experiment is finding the specific heat capacity of a liquid. So I'm drawing the drawing. You guys wait, okay? Don't draw it yet. Alright, guys. Sorry. Yes, please start drawing now. जी 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 सब ठीक है. Alright, everyone. You guys done? 0331 505 4949. Okay, you guys done? Should I start now explaining this?
Yes, sir.
Okay. So what you guys need to do, ये तानिया पंखा बंद करके दरवाज़ा बंद करके जाना. Okay. So now, first of all, we know that if you look at this, there is no insulation over it. If there is no insulation, it would mean that heat loss
Already
is, heat loss is going to occur. Okay. So to basically, that means that our equation will be energy supplied by heater would be equal to energy gained by water plus heat loss to surroundings. So I'm just gonna move it a bit here. Okay. Everybody's clear about it? Alright, now
Sir, is it energy given by water?
gained by water, because energy is being supplied to water. Okay. Alright, everybody, should I go on now? So we're gonna take the first reading. So energy given by the heater would be E. Well, we're going to write, in fact, we must write power, change color please, power 1 times time equals to mass 1 times C times the change in temperature. So that is basically the equation. And we are going to denote, we're going to just say that the heat loss that we don't know exactly how much it is, we're going to call it H. Is it clear? Because there's going to be some heat loss as well, that's why. Then what you're going to do is you guys need to take another reading. I'll explain why. For that reading, we will change the power so that we have a different amount of energy supplied by the heater for the same amount of time. We'll have to move more or less mass through the tube so that it can give us the same change in temperature. Is it clear?
Can you explain again?
So let's suppose T1 was 20 degrees and T2 was 40 degrees. So we want the change of temperature, basically water to be heated from 20 to 40, right? So what we're doing is, let's suppose the heater was supplying like 2000 joules of energy and the mass that was flowing through it was say 2 kilograms, right? Now I need to keep this temperature before and after same. So if I keep it same and now I increase the energy supplied by heater to 4000, which means then to keep the temperature same, we also need to increase the amount of mass going through it. Is it clear? So the ratio remains the same. Understood? So what we have done is we have changed the power of the heater and we have basically tried that we get larger amount of energy from heater for a larger amount of mass so that it can reach the same temperature in the same amount of time. Is it clear? Just like if you heat water in a pan, so larger mass, if there is more water, so then you will have to give it more energy so that it can be heated in the same amount of time to the same temperature. Do you guys understand this? Yes? Tamoshi, I can't understand what you're saying.
It wasn't me.
Okay. So then, in this one, we will also get the same amount of heat loss. Now, the next step is that you subtract these two equations. If you subtract them, so power 2 times T minus power 1 times T. So for the different mass it will be M2 minus M1, so you'll get the change in mass and the rest of the things are going to be the same. But interestingly, when you do H minus H, this whole thing will become 0 because it cancels out. Do you guys understand? So what we're really doing in this one is we need to keep the change in temperature constant. So when I increase the energy, I will also increase the amount of mass in the tube. Is it clear, everybody? Now why do I need to keep the temperature constant? Because for same amount of temperature, I will be able to keep the energy loss the same in both readings, and that's what you guys need to understand. Okay, is it clear?
Yes.
All right. So this is a bit of a tricky thing, but once you understand this, that all we need to do is change the power, change the mass, and rest of the things remain the same. So that when we subtract the equations, the heat loss is subtracted from it, and then we can actually get the accurate value of heat capacity. Otherwise, it would not give us the accurate value. Is it clear? Right.
Sir, can you re-explain this? I didn't understand.
Yes. So what I'm basically saying in this experiment is that suppose we have a bucket of water that needs to go from 20 degrees to 60 degrees in 5 minutes, right? And it has 2 kg of water. So I see that when I give a heat that is basically 2000 joules, it basically reaches 60 in 5 minutes. Is it clear? By using the thermometers. Okay?
Yeah.
Now, along with this, some of the heat is transferred to the water, but also some of the heat is lost to the surroundings, which I'm calling H, right? Now, in the next reading, what I do is I take larger amount of water, but I need to keep, I want it to go from 20 to 60 in 5 minutes. Now, I know that if I take it as 4 kg, so it won't be possible to heat it in 5 minutes because 2 kg gets heated in 5 minutes for the same amount. So what I'll do is I will increase the amount of heat supplied to it to 4000 then. Do you understand what I'm saying? So by doing so, by increasing the mass, I also increase the energy supplied, but the heat loss that is going outside would be the same because both have the same temperature. Heat loss depends on the temperature difference between the atmosphere around it and the object itself. Do you understand? So notice the equations. In the first equation, what I've done is I've actually kept some energies because energy is power into time, right? And then I changed the power so that I could heat larger mass in the same amount of time to the same temperature. Is it clear, Chavez?
Yes, sir, but why did we do this?
Because we exactly don't know how much heat energy is being lost to the surroundings. So when you subtract these two equations, you see this will give us the change in energy. This will give us basically the change in mass times C and delta theta, of course. And here H minus H will be 0. So we want to eliminate the heat loss. Understood? So this way we can get the most accurate value of heat capacity. Understood?
Yes, sir.
That's why we need to remove the heat loss. Any questions, anybody? Okay. So I know this is a bit tricky, but you just need to understand and follow what I've written, that you have to keep the temperature change same, and in order to do that for the same amount of time, you need to change the mass and the energy only. Then you would subtract both equations and find the value of heat capacity. And the reason to subtract these two are that we want the temperature to be same so that the heat loss outside is the same. Okay? Got my point?
Yes, sir.
Okay, so when the time ends, okay, I want everybody to basically rejoin the class. Okay. You can write this down while I'm taking out the question.
Excuse me, sir.
Yes.
So the difference between the heat losses is zero.
Yes.
So they are the same.
Yes, and they will be same if the temperature change is the same in both the equations, right?
Okay. Thank you.
There's something you guys need to, basically you don't need to know, but I'm just telling you. If let's suppose your room is 23 degrees and outside it is 38 degrees, so a certain amount of heat loss is going to be there. But if your room is 38 degrees and outside there is also 38 degrees, the heat loss will be zero, because heat always travels from like uh, basically more to less. Do you understand? So
Yes.
we need to make sure that the difference in temperature is the same so that the heat loss is the same in both the reading. If the difference in temperature is not the same, then basically heat loss will be different in each reading, and that would cause an error, right? I hope you guys understand this. Okay. All right. Everybody's written this then?
Yes, sir.
Okay. Just hold on a second now. Okay, so a similar experiment came into our exam, and I'm going to show you the question so you guys are aware what exactly we need to do. I'm just posting it. Hold on. Generally, the questions would be easier than this, but in paper 6, that's your um, the ATP paper, they might ask you certain questions, so we got to be prepared for that. That's why I gave you a detailed understanding. Now let's look at this. So it says an object of mass m, heat capacity, supplied quantity of thermal energy q. The temperature increases by this. Write down the expression. So we know that q, okay, c is equal to q over m delta theta, right?
Yes.
Now this is the same reading. This is the almost the same, the drawing that I got you. So they say cold water in, hot water out. It says cold water at 15 degree flows at a rate of this meter cube per minute. Hot water flows out at the same rate. Calculate the mass of water that passes through the heating element in 1 minute. The density of water is this. Okay. So first of all, we are going to find the volume. Here is 0.0036 meter cube. The density is 1000 kg per meter cube, and mass is what we need to find. So density is mass over volume. So mass is going to be 1000 times 0.0036. Is it clear? So this is going to be 3.6 kilograms, right? Now, it says that the power of heating element is 8.5 kilowatts. Calculate the temperature of hot water that flows out, the specific heat capacity. Okay. So we are going to do power. Basically, energy is equal to mc delta theta. Energy is power into time. Mass we already know. So we're going to put in the values. So power was 8.5, kilo is 10 raised to power 3. The time wait a second. It's basically a minute, which is 60 seconds. The mass is 3.6. The heat capacity is 4200 times delta theta. So when we use the calculator to do this, it's going to be 8.5 times 10 power 3 times 60. Answer divided by 3.6 and divided by 4200. So the change in temperature is going to be 33.73 degrees. Now, what you going to do next? The water in was going at 15, so the change in temperature is the final temperature minus the initial temperature. So this is 33.73. Final temperature is what we need, so let's call this T, and the initial temperature was 15. So we're gonna take it there. It is going to be added up. So the final temperature is going to be 48.7 degrees. That's why it is 7 mark. Okay, 4 mark. Is it clear, everybody?
Can you explain the first part again?
Yes. We know that the energy supplied from the heater is equal to mass times heat capacity times change in temperature, right? You know this equation, right? Energy,
No, sir, not this, the first part.
this one.
Yeah.
So it says that cold water 15 degrees flows at a rate of this. If you look at this, right, what is meter cube? That's volume, right? So in 1 minute, this is the amount of volume going. So I wrote the volume. The density is this. I got the mass by density is equal to mass over volume, because he wants us to find the mass that flows in 1 minute. Understood?
Yes, sir.
Sir,
Yes.
do we always change minutes to seconds?
Yes. Especially if you see watts, because watt is an SI unit and seconds are also SI unit. You cannot put it in minutes. Okay. Sometimes, however, he's going to give, let's suppose he gives this reading. I'm just writing it for your information. Let's suppose he gives this reading as 4.2 joules per gram per degree Celsius, and you're on, then you got to change the mass into grams because there is gram in it. Understood? But right now it is kg, so we could put it to kg. Watt means basically it's an SI unit, so we need to convert time into SI units as well. Okay, Thamushi? Did I answer your question correctly then? Okay. Any other question? Now, in this also, they might ask you, like in the fourth part, I'm just writing it on my own. In the third part, they say the temperature will be different in reality than what is calculated in part 2. Suggest a reason why. So this is the type of question they're going to ask. So what do you think? Why would the temperature be different in reality than the one we have calculated?
Plus, we lose heat to the surroundings.
Because, sorry? Yes,
Because
yes.
we lose heat to
Yeah,
surroundings.
yes, because some of the heat is also lost to surroundings. Everybody understands this now? Any questions? Please let me know. Right. Okay. So I believe that is the end of this chapter. Tomorrow, what you're going to do is we will have to work on a worksheet.